So in this video I'll run through what's needed for quiz 2, which will be relative formula mass, law of conservation of mass, and then writing state symbols in equations. So starting with the relative formula mass, it's just the total mass of all of the atoms in a formula. You can find the mass of an atom by using the mass number on the periodic table, although typically this will be given to you in the question. Once you know the mass of each atom, you just need to add up all of those masses to find the relative formula mass. So if we look at an example, I've got the formula here for water, H2O. The formula tells me that I've got 2 hydrogen atoms and 1 oxygen atom. Using my periodic table, I can see that hydrogen has a mass of 1 and oxygen has a mass of 16. To calculate the relative formula mass, I need to add those masses together. So because I've got 2 hydrogens, I'm going to have 1 plus 1, and then 1 oxygen plus 16 gives me a total mass of 18. Another example, H2SO4. I've got hydrogen, sulfur and oxygen, and I've got the masses of those atoms written here. My formula tells me that I've got 2 hydrogens, which is why I've got 1 plus 1, 1 sulfur, I've got 32 for sulfur, and 4 oxygens. So 16 times 4 to represent the 4 oxygens, and I add that up and I get 98. The only place that students typically go wrong with this is if they don't read the formula correctly, and that's mostly an issue when there's a bracket in the formula. So here I've got Ca bracket OH bracket 2. Similar to maths, anytime you've got something in the bracket, you multiply it by the number outside the bracket. So calcium is not in the bracket, so I do not multiply it by 2. That means I've only got 1 calcium. Oxygen is in the bracket, I do multiply it by 2, so I've got 2 oxygens, and similarly I've got 2 hydrogens. So I'm getting the relative formula mass. I know I have got 1 calcium with a mass of 40. I've got 2 oxygens, each of them will have a mass of 16, so it's going to be 16 plus 16. And I've got 2 hydrogens, each with a mass of 1. So I add that all up together and I get 74 as the relative formula mass. Slightly harder example, also with a bracket, this is calcium nitrate. Calcium is not inside the bracket, so I do not multiply it by 2. That means I've only got 1 calcium, which has a mass of 40. Nitrogen is inside the bracket, so I do multiply it by 2. I've got 2 nitrogens, each nitrogen has a mass of 14, so it's going to be 14 plus 14. Oxygen is inside the bracket. I've got 3 oxygens inside the bracket, and I need to multiply that by 2. So 3 multiplied by 2 is 6. I've got 6 oxygens in total. Each oxygen has a mass of 16, and I've got 6 of them. And I add up those numbers to work out the formula mass, and I end up with an answer of 164. The last one, aluminium sulfate, okay? Aluminium is not in the bracket, but it is followed by the number 2. That tells me I've got 2 aluminium, so I'm going to have 27 plus 27, as 27 is the mass of my aluminium. Sulfur is inside the bracket. I multiply it by the number outside. That means I've got 3 sulfurs. Each sulfur has a mass of 32, so I'm going to do 32 times 3 to represent my 3 sulfurs. And then I've got 4 oxygens inside the bracket and then a 3 outside the bracket. Again, bracket means multiply, just like it does in maths. So I've got 4 times 3 is 12. I've got 12 oxygens in total. Each oxygen has a mass of 16, which is going to give me 16 times 12. I add all of that together and I get an answer of 342. Okay, so that is how you calculate relative atomic mass. The other thing I asked you to do was look at law of conservation of mass. This is really straightforward. It just says that whatever the mass of your reactants, the total mass of your reactants, and the total mass of your products will be exactly the same. So in this reaction, I start off with 12.4 grams of my reactants. That means I must produce 12.4 grams of products. You're told that 8 grams is copper oxide. That means 4.4 must be carbon dioxide because in total the 2 masses must add to 12.4. There's a few other examples in your quiz booklet, okay, but they're all done exactly the same way. The total mass on the left must equal the total mass on the right. So here on the left I've got 8 grams for my reactants. I must have 8 grams for my product. If 6 is calcium oxide, then 2 must be carbon dioxide. Here, I don't have the mass of my reactants, but I do of my products. If I'm producing 5 tons of lead oxide and 1 ton of carbon dioxide, I've got 6 tons of product in total. That means I must have started with 6 tons of my reactants. And then here, I've got aluminium and oxygen forming aluminium oxide. I can see that I've got 10.2 grams of my product. That must mean that I started off with 10.2 grams of reactants. If 5.4 grams is aluminium, then the remaining 4.8 grams must be oxygen. So law of conservation of mass just says mass is conserved in a chemical reaction. That means the total mass of the reactants must equal the total mass of the products. The last thing we're asked to do is practice using state symbols. So I've told you what the different state symbols are and when they should be used. So solid is S, liquid, or they can use the word molten. They both mean the same thing. You'd use the state symbol L, gas is G. And then for AQ, if they use the word aqueous, solution, or dissolved in water, you will use the state symbol AQ. Sometimes they'll tell you if something's a solid, a liquid, or a gas. Sometimes they'll expect you to know. In the cases of acids or alkalis, they will always have the state symbol AQ. So if you're told you've got an acid, you're expected to know that that state symbol is AQ. Similarly, with an alkali, you're supposed to know it's AQ. So if we look at the first question, the solid calcium carbonate. I'm being told that it's a solid. If I know it's a solid, I'm going to be using the state symbol S. Was added to hydrochloric acid. Okay, because it's an acid, I'm expected to know that the state symbol is going to be AQ. To make the solution calcium chloride. If you see that word solution, it means it's aqueous. So I'm using the state symbol AQ. I also make water. So here I've given you the state symbol for water, but you are expected to know that at room temperature, water is a liquid. So you'll be using the state symbol L. And then carbon dioxide. Again, I gave you the symbol G for carbon dioxide, but you would be expected to know that CO2 is a gas, okay? A common mistake here is that students write AQ for water, okay? To be aqueous, you need to have something dissolved in water. If you've just got water by itself, then you use the state symbol L because it is just a liquid. The next one, a solution of chlorine. If I see that word solution, okay, that means it's going to be aqueous, so I'm going to write AQ. Was added to aqueous sodium iodide. If I see the word aqueous, I know it's going to be AQ. To form sodium chloride, so I haven't told you in the question, but I've given you the state symbol here, and iodine. Fill in the missing state symbols, okay? So that's all you would have to do there. Just be aware of acids and alkalis, and other than that, just make sure you know the different words for AQ. Aqueous, solution, or dissolved in water all mean exactly the same thing.